All right, so first of all, we haven't got into assemblies yet, so it's a new file. We're going to go up here to File, and we're going to go to New, and we're going to choose Assembly. I like to have a File Explorer open. So if you open up Windows Explorer, and then go to the Student Data folder, My Name, SOLIDWORKS, there's an assembly folder in there, and I'm going to start with the shaft support. I like to have the shaft support open in the File Explorer. When an assembly opens up in SOLIDWORKS, it automatically opens up with asking you to insert a component. If you do not have a component open, then it asks you if you want to browse for that component. I don't really like browsing for a component because when you put one in, then it kicks you out. Then you got to go browse and find another one, and it kicks you out, and browse and find another one. If you have your browser open, then I can just take the file from the browser, the base plate, left click on it, and drag it into the assembly and let go. So instead of having to browse for that within SOLIDWORKS, I can just drag parts into my assembly. The most important thing you need to know about bringing in the first one is that it's fixed. You drag it in, it has an F by it, it's fixed. I can't move it. I cannot take this part and move it because it's fixed in this environment. The next one I bring in, doesn't really matter what order, drag in the bearing, drag in the cap screw, drag in the collar. Oh, I need 2 cap screws, right? Drag in another one. Okay. Those do not have an F by them. They are floating. I can take in those parts and move them anywhere I want, or rotate them any way I want in the environment. They have what are called 6 degrees of freedom. What am I talking about 6 degrees of freedom?
3, but also in relation to the 3 that the fixed applies.
You can move them in X and Y and Z. So I can move them positive Z, negative Z. That's 2, right? I can move them positive and negative X, positive, negative Y. And I can also rotate them about the Z, rotate them about the X, and rotate them about the Y. So they have 6 degrees of freedom. If you hit the glasses, you can view the origins of these individual parts and see which way they are oriented, X, Y, and Z coordinates. Even though the base plate was the first one I brought in, it made it fixed. It doesn't matter. The first part that brings into the assembly, it's fixed. If you don't like that, you can right-click on the part, you can float it, and I can move that part anywhere I want. Okay? If you right-click on a part and fix it, it has the F next to it, it's fixed. I cannot move it. If you right-click on it in the browser and float it, now I can float it and put it anywhere I want. It is my suggestion when you're starting an assembly to take one of those parts and determine it as the base feature or base part and lock or mate that part to the environment. These 2 coordinate systems are the same. This coordinate system I have selected here is the environment coordinate system. The coordinate system that's down here is on that part. I can mate between coordinate system and coordinate system and then say okay. Even though that part is floating, it is now constrained to the coordinate system of the environment and I cannot move it or rotate it. Is there a question about that?
So you can't rotate the whole screen? You couldn't look on the other side of it?
Oh, I can rotate the view.
Oh, okay.
I just can't take the part, move the part, or rotate the part. To go a little, well, any mates that you put into the assembly are listed here in the browser. So if you make a mistake and put a mate on there you don't want, then go over into the browser, right click, and delete it. You can remove that mate, then I can move that part. To go into a little bit more detail, I can mate the back side of this part to the front plane. I can mate the left side of the part to the right plane. And I can mate the underside or bottom of the part to the top plane. So I have removed all the degrees of freedom of that part, and I have mated it to the planes of the environment. So I need you to use your mates and orient your first base part within that environment before you start attaching or mating any of the other remaining parts in the assembly. Clear before I move on? Okay, so right now with this one, I'm just using basic mates. So if I go up here to mate, they're just coincident, parallel, perpendicular, tangent, concentric. I'm just using these basic mates. I do have a couple of assemblies you're going to do where you're going to use some of the more advanced mates, like mechanical mates, like a rack and pinion or a gear. So there are other mates, but for these first ones, we'll stick with just the standard mates. To mate objects together, you just pick on their geometry. So if I choose this bottom circle of this hole, which needs to line up with the left circle on the base, it will mate those two together. All that did was make those two concentric. If I get out of my mating system and drag it, you can see it goes up and down on that axis, and it can rotate. I can rotate it about that axis. All I did by picking the two circles was line up the axis of both holes. So if I want to then connect the two surfaces, I would go back to mate, pick the bottom face of the bearing, and put the top face of the base, and I have put those two faces together, so I've stopped it from moving along the axis of the holes, but I have not stopped it from rotating. Okay? So I still have to go in and mate the bottom hole on the right side of the bearing and the top of the hole on the base, and I get those two holes lined up and stop it from rotating.
If the holes are different sizes, will it mate by the center of it?
Yes. Okay, but I'm glad you started that conversation, because if the two holes were a different distance on the base than they are in the bearing, then the mate would fail.
Okay.
If the two axes don't line up, then it won't, line up that last one. Okay. Continuing to mate, I can mate surfaces. So I can mate this top surface to this top surface, but it's not. The two surfaces are lined up, right? And then I can do something like mate the cylinder and the cylinder. I mean, there's multiple ways you can do it. Continuing, try this one. With the mate tool on, I can grab that circle, left click and hold, and come on. I know I can do this. Is that turned off? There's no way. I know I can do that. It has to be turned off because I know you can do that. Mate, you should be able to drag that on into that hole. It must be turned off in the options. I'm gonna have to go look. I'm gonna try it again. Mate this top circle to this one, and then you might have to, because of the orientation of the face, flip it and say okay. Some people like to move their parts and rotate their parts so that they're close to or oriented in the right position before they assemble it. I don't know. You don't have to. You do not have to. You can use the mates to position those where they belong. So the first one was upside down when I mated it, so it went upside down on the mate. All I had to do was flip it. The second one, I oriented the correct direction, so when I mated it, I didn't have to flip it. On those screws, you can still turn them, right?
I was gonna ask you.
Okay, because all I did was mate the two faces of the circles and the axis. I only really want you to put things together today. This exercise here, I usually turn on the axis so I can see it, then when I'm done, turn it off. But I just want you to put it together. We will change materials. We will make an exploded view. We'll put it onto a drawing. But that's Tuesday. Today, I just want you to put an assembly together and kind of hopefully listen to the things that I've talked about how it goes together. There's another one I want you to try. It's the wheel. So there's an axle, base plate, bracket, two brackets you'll need, and a wheel. The design of this assembly is horrible. But what I want you to do is put it together, and then we can have a discussion about why it's bad, and then I want to adjust the assembly or adjust the parts within the assembly and make it a better design. So I can kind of give you a reason for why you would want to put assemblies together in SolidWorks. Okay? Questions about how I put this one together?
I have one question. If, let's say, like when you put that screw in upside down and you mated those two surfaces, if you were to click the check mark, will it let you, like the head of the screw would have been inside the metal and would have two pieces of metal taking up the same space? Will it let you do that?
Okay, let's do this. This is kind of an idea of why I can go back to my assemblies. My mates, and delete them if I want to. And let's say I put this together different.
Let's say you made it.
Let's say I made a mistake and I mated the top face here to this bottom face down here, so it's overlapping.
Yeah.
Right? It'll let you mate it so it's overlapping.
It will.
But what's really cool is I can come up here to my tools and say interference detection and calculate the interference detection, and this program will tell you how much it's interfering and where it's interfering.
Oh, that's cool.
So it'll show you all the interferences and how much it's interfering. And after you get this assembled, I will do some more explanation about this, but why is it telling me that my screws are interfering?
Because the threads are bigger than the...
Because the threads are cosmetic, and the outside diameter of my screw is bigger than the inside diameter of my hole. So it's showing you the interference of the screws.
It's like you haven't tapped the hole yet.
Correct. It's not been tapped. It's just a representation of the threads, not true threads. So it will show you all the interferences that you have and even give you the volume of that interference. Pretty cool?
Very cool.
So I'd like to have you put it together or try to put it together and and then we can talk some more about what it is that you have with this assembly.